My legs heavy, I don't get it. How come I haven't hit it already? Still working, I'm still learning, I'm still searching, finally earning something, finally turning something called a profit. If I hear you talking shit, don't get caught in it. I'll be popping off and hit your ass, dropping all your shit. Yeah, I promise this, I got promises. You ain't stopping this, cross my shit, you'll be knocked unconscious, bitch. That's the consequence, I got this, I will not quit. Man, I'm on it, honest. I'm gonna launch quick, then I'm gone. It's just a matter of time before I'm over the climb and moving under my prime. Just quit my 9 to 5, I'm rocking, and they watching, cause it's shocking. Dropping all these top 10 songs, so stopping. It's time to live my life, it's time to live, not die.
Hey, what's up, guys? So I did an interview a few months ago with Dandy, and he's basically is really interested in the Apollo missions and the moon landings, and he kind of grew up, just fully engulfed in it, and what it took to actually get to the moon. We had a good long conversation, and he really was able to explain a lot of the things that you don't really hear too much in the mainstream NASA Apollo missions narrative. And I think it's really informative, and it kind of gives you a better idea of what was going on at the time, and what it actually really took to get to the moon. So I hope you guys enjoy it.
Learned a whole bunch of stuff about it. Anytime I need to ask a question about the moon landings, I go, "Hey, Dandy, have you heard this?" And he's like, "Oh yeah, let me tell you." And it's like a 30-minute thing where he tells me all the details about this.
I'm very long-winded. I'm sorry.
No, it's good. No, it's good. I like it.
Yeah, and I appreciate you doing this, Stanley. It does mean a lot to me that you took the time to get a hold of him and have someone explain stuff to me that I have questions about, because I do have a lot of holes in what I know about it. So I definitely want to learn more about it.
All right, cool. I'm going to stay out of the way. I just wanted to say that real quick.
All right, no problem.
Yeah.
Thank you. I think one of the main things that confuses me and maybe will help my understanding is how. So I understand how they would have gotten there with the with orbiting to slingshot.
Mm-hmm.
My thing has always my big question has always been, how did they get there the 3 days, and then the time back would be the same, if not having the same ability to have the same the same slingshot and the same propulsion. If that
So okay, so you're saying the time there should be the same as the time back. It should
well,
take the same amount of time.
I don't understand how it was the same there, same back. If that's even was even the truth, even how it worked. Because I've always known it to be 3 days there. They did their moon mission and then 3 days back. If that is
Yeah, that's
yeah.
It's I mean it's it's pretty close to the same amount of time. Yeah.
Yeah, so I can see, and when I'm trying to imagine what it took to do that, where they use the Earth's gravity and they use the orbit to slingshot there, but I don't get how they were able to have the same propulsion to get back in the same amount of time. If that makes sense to the question.
Okay. I mean I guess I kind of understand. Well, you have with rockets, especially like the shuttle, the Saturn V. These are the ones that I know the most about. Like the Saturn V is probably the one I know the most about.
Mm.
But this thing at liftoff, it has the amount of weight, fuel and everything else to get it off the pad. It's like, well, you have to have more fuel that adds more weight and so forth. So you have this trade-off, and this thing is burning like an Olympic-sized swimming pool of fuel every second at startup, and we're talking millions of horsepower this thing is creating. And as it's doing that, it's dumping, like I said, an Olympic-sized swimming pool of fuel every second. And as it does that, it starts to lose weight. So it's getting skinny, basically.
Mm-hmm.
And it's just enough to get it to start lifting off. And the more this thing lifts off, the more weight it's dropping, the more thrust you see. So this thing is at 100% at liftoff, and it gets it going pretty fast. So it's almost like It's kind of like whenever you were a kid and your dad was pushing you on the swing. It gives you a little push. That's the first stage. So it drops off. All that weight from the first stage drops off, but you're hauling ass already.
Mm.
I mean, you're going real quick. And the second stage kicks in. So you have 5 of these enormous rockets, these enormous engines at startup, these F1s, and they're done. They drop off. I don't know how many tons it is, but it's an enormous amount of weight. Then you have 3 more start up and they kick in. That's the second stage. And that thing gets them really moving. So now they're into Earth orbit. It drops off, second stage. And now they've got the third stage, which is in this command service module. This is the one that they can start and stop. And it's a single J2. And because we're dealing with so much less weight, it's like an eighth of the weight. And it's already going around 17,000 miles an hour in this orbit. Then it starts to change that orbit and speed up. And then it does the little figure 8, what you're talking about, which is in this orbit that could actually bring them back to Earth.
Okay.
So the only way that they can stop that from happening is to slow down. And that's what happens all the way there. So they do TLI, which is this translunar injection, to boost them out to the moon. And that's as soon as they stop that engine, they're going around, I think, in between 25 and 26,000 miles an hour, depending on which mission we're talking about.
That was what set the record for a manned craft, right?
I think Apollo 8 did it, or it's either Apollo 8 or Apollo 13. They were the ones that went the furthest. I think it was Apollo 13 because they did that. They stayed on that free return trajectory.
Okay.
And they went the furthest away from the Earth. Like they were the ones who made it the farthest away because of that particular. They never went into orbit, around the moon. They were the only ones who went out to the moon. 8 was the first.
Thank you.
9 was Earth orbit with the lunar module, checking that out for the first time. 10 took the lunar module out to the moon and simulated. They went all the way, I think it was like 11 miles above the surface.
Wow.
And then they did their abort and came back and rendezvoused with the command service module and then came back home. So once you stop the engines at let's just say 26,000 miles an hour is what they have to get to. Well, they're slowing. As soon as they stop the engines, they begin to slow down because they're so close to the Earth, and the Earth is actually tugging on them. And they keep slowing down and slowing down and slowing down until they get really close to the moon. And then the moon, the gravity of the moon actually starts to take over. And you can actually watch this in real time, the data that was coming back. I've actually watched this. Like it's updating like every couple of seconds. Their speed is updated. So you can sit there and watch it drag for days. And then all of a sudden it starts to slightly speed up and slightly speed up faster. And then it's exponential. And now they're at the moon. The only way that they're going to get into an orbit around the moon is to slow way down.
Yeah, that was kind of one of the things that confused me because I got the how they got the trajectory that you're saying with the thrust and the slingshot, but when I was reading about it, it was talking about how they had to slow down enough for the moon's gravity to actually for them to actually get into the moon's gravity.
Yes.
And then I believe it said something they had to slow again to launch, or I guess it, or maybe I'm adding a slowdown.
Oh yeah, well of course the lunar module has to slow down, because they're together. So after TLI, the translunar injection, whenever they actually hit the speed to get out of the pull of the Earth and head out to the moon, they have to connect and dock with the lunar module. So it's in this bay in this humongous thing. So they burst the panels off of it, they release themselves, and then they turn the thing around 180 degrees, and then they dock with the lunar module, and they pull it out. And then that's that. So you have this, the S4B, which is this booster that's helping them get to the moon.
Mm.
They eject the S4B at that point. This is the one that just, created all this velocity
Okay.
to get them out there. So they get rid of that. So they're shedding weight. So it takes way less thrust, to do anything at that point. So before, it's like moving a big heavy piano. Well, now you just, you removed all the keys, you took the harp out of it, all the strings, all this weight. Now it's really easy to move. The more and more fuel you get rid of, everything is being shed off as soon as possible to get rid of this weight. So it's, way more fuel efficient. Instead of hauling a big trailer full of furniture in your truck, to move across town, that you get terrible gas mileage, and then
Okay.
so it's basically the exact same principle.
So
this.
It kind of just hit me. So basically, where they had to do the lunar slingshot to get back, they're doing it with such less weight that it's almost
Right.
equal to what they were doing to get to the moon from Earth.
It takes way less thrust.
Yeah, in a
way
sense.
less
Okay.
thrust.
See, that explains a lot more to me now. I'm see now. I'm starting to get. I'm starting to see it now. How it worked. Please continue, please.
Okay, so let's just pretend that the lunar module has just finished everything on the surface, and it rendezvous with the orbiting command module that's going around the moon. It's just doing that over and over and over again. Now they have a window that they have to launch and try to catch up with this thing.
Yeah.
And the particular engine that they're using is using hypergolic fuels, meaning that it's like an epoxy where you put these two things together and, it hardens. Well, in this case, these two particular fuels, and they're extremely corrosive. They're so corrosive that they were never able to actually test the particular engine, the ascent engine. Otherwise, it would have. Yeah, it's crazy. Like, they would design this thing and they would test all these things on Earth, but the very engine that they used in every mission to the moon was never tested, because like that exact engine was not tested. So it had to be perfect. It had to be. There was no other option. If that engine did not light, then they would have been doomed on the moon.
I have a question, because someone actually said something earlier today in the Discord server, and it kind of dawned on me. Were these missions, were they like, maybe maybe it's a opinion or maybe a belief not told to everyone, but were these almost suicide missions for these guys?
I mean, they say it was like 50-50, but I don't really buy the whole 50-50. I think that's new. Absolutely, there was a chance for failure. Something could break. I mean, there's
just like
millions
a test
of things that exactly, and most of these guys were, and a lot of them actually died in these tests. If you go back and read, I mean, just look at any experimental vehicle, experimental airplane or jet or rocket these guys were strapping themselves into. This is the type of thing that they were like Evel Knievel. They were adrenaline junkies. That's what they were.
Yeah, and I think a lot of the Apollo hoax may be upon that too, because I know how Russia hid and kept secret as much as they could the amount of people they lost during the race. And I think because maybe America doesn't even, or NASA doesn't give that information out about how many people actually passed in the testing of anything to do with space. I think that may be a lot of it, because there's a person in the server that almost has an idea that it was like they flipped a coin and they put them in the first rocket they built and they took off and and I think because NASA doesn't talk about the testing phases of NASA, maybe that's a big part of the hoax as well.
Yeah, just the stuff I mean, over the years, this stuff has trickled out, people have actually gone to these places, like these different museums and these different backyards and people's basements, and just like the people who work there. I mean, they brought this stuff home because it was getting trashed. It's like, I mean, people just can't believe that.
Yeah, yeah.
They just can't believe that this stuff just went to the wayside. And on one hand, I totally understand. And I'm not the type of person that's like, no, that's just not how it works. Let me explain to you, because this was all crap and they didn't see any use in it. Part of it is actually that, if you work in a business that has to actually design a tool in order to make a tool that you're going to use on this mission, you created a tool at your, I mean, there's 12,000 something different organizations, different
parts,
contractors who built things for these, and they had to make some tools. Like some people actually had the tools already, and that's why they got the contract. But a lot of these people had to actually make the tools and redesign the welding machines. They couldn't weld this shit for anything. It took them forever to figure out how to weld these gigantic pieces of rocket together. And one of the main things was you have two different fuels that are right next to each other, and there's a difference of 300 degrees. So they use this common bulkhead, and that common bulkhead to shed weight. I mean, they got rid of several tons by using this common bulkhead. So instead of two cylinders with rounded tops, like you would see a CO2 cartridge, say, instead of two of those stacked together, imagine if they just created one common bulkhead that's the top of that rounded radius of that cylinder just completely matches, so it's like a male and a female fitting together. That's how they did this, and they were able to shed like tons of weight. So, and I mean, that was a huge, I mean, there's so many little things like that had to happen in order to make this thing. I mean, the fact that the lunar rover went is, I mean, that thing was really heavy. I mean, they almost didn't bring it. They had actually given up on the idea, and an engineer at GM decided to just make a model and then bring it in there and show them, because they wanted to, they wanted that contract.
So it's almost like, it's almost like each section probably was built 100 times before they figured out which one they wanted. And
oh man, there's so many revisions to this stuff. You can see it. I mean, there's photos of this stuff being built, and it changes so much over time. Like the fact that the lunar module looks the way it does, that's the thing that people pick on the most. And they're looking at something that's one of the most amazing machines ever built. If you're like, why does it look like that? Why is there this, it looks like cardboard on the side of it with some duct tape? It's like, yeah, that's pretty much what it is. And there's a reason for that. There's definitely a reason why it looks that way, and why it's just kind of thrown on there like that with tape. And it is tape. It's really special tape, but this,
I would like to think it was duct tape.
I mean, some of it was. They called it gray tape. I don't know if it was duct tape, but it was gray tape. It was just simple gray tape, Oh
wow!
And I mean, they used it on the surface of the moon. It's like,
now
it didn't have to last long,
Would this be the exact reason why, say, they can't add 5 or 6 cameras onto a rocket?
Like, oh, you mean like
weight,
now?
Yeah, like weight distribution, like just because it seems like, and I'm imagining it, that they had to constantly streamline to get to the best weight and the most efficient weight. And to me, when I think that, I'm thinking even 60 pounds is a big deal when you're building a rocket to go into space, or even rockets to get someone to the moon. So adding cameras to a rocket isn't just like, in my mind I'm thinking just add cameras, but realistically, it's just more weight they're having to do something with.
Right. Yeah. I mean, it definitely is. There's this whole weight thing. It's like for each pound there is I don't remember like how many gallons of fuel it is, but it's like it's more than 1 gallon of fuel per pound. So it is actually pretty it's pretty crazy. I'll tell you how crazy it is. I'll tell you how important weight was. At the time, they paid Northrop Grumman, which was the engineers, the company that developed the lunar module.
Mm-hmm.
They paid them $50,000 per pound that they could shed, and this is $50,000 in those days, not today's dollars.
Okay, yeah.
So who knows how? I don't know what the exchange rate and all that is. But
and the funny thing is I actually do. So it'd be around $275,000 today's money. I did a lot of research recently on NASA's budget. So it's funny that you brought those numbers up because it instantly popped into my head. I can definitely understand how important shedding that weight would be to both parties.
Yeah. I mean, these people, like, I mean, right now I work at a manufacturing plant, and we have 8 engineers here. You could come in here with a drawing that you made when you were drunk in a bar with a crayon on a napkin, okay, and say, this is my idea for a new toilet seat. I want this, make this. And we will design that in CAD. We will show it to you, show you what it's going to look like. You can pick the color, the type of material that you would make it out of. You could do metal injection molding, which is a process where we mix metal, steel particles with a plastic, and we do a 30%. I mean, we're talking about plus or minus 1/1000th of an inch, tolerances on a part like this. And then once we do it, it's like 30 or 33% larger than it should be. And we know that. That's how we designed it. And then we bake it for a long time at a really high temperature and pressure. It's called sintering. And it bakes all the plastic out of it, and it leaves the steel. So you have a stainless steel part now. And you've done that with injection molding instead of, it's not cast.
Yeah.
And it's not machined, but it's almost just as good as machined. And we're talking about, like, this is amazing type stuff, and to do this for people like Bond Arms is one of our customers, like AMS. We have several different like gun manufacturers that really want these parts, and they want them quick. They want them fast and cheap. And we can do this very quick, fast, and cheap. We can make 3 parts a minute instead of having to machine those. Imagine how long it would take you to machine those with a CNC.
Well, how big of a project can you do at a time when you're doing that?
We can do parts that are like so small you can barely see them with a microscope, made out of silicone, or we can make something as large as a kayak.
Wow.
And we can do this in like such high resolution, pretty much any texture that you want. With any color and any type of plastic. And there's hundreds of different plastics that you can use, and they're all for different things. And we have so many different processes that we can use to make your parts. But anyway, the point of me telling you that is the fact that at this company that I'm working for, we get this all the time. Some customer will come to us and they'll be like, hey, look, here is what we need. We need this. Can you do this? And it's like, man, we're experts at that. And we have no idea how to do it. So what we do is we hire an expert who does know how to do it.
Yeah.
Get them. So we buy the machine, the special machine that can do this particular project that we need for this customer. We hire a professional who knows what they're doing at this, come in here, show us how to do it, stay here a week, make sure that we can make that part. And now we know. Now we know how to make something out of silicone. Now we know how to make metal injection molded parts. Now we know how to make lumbar cores that go in your back that replace the discs in your back. They're $25,000 a part. Like we make all of this, and it's amazing. This is the type of incentive Grumman had when they're talking about saving 1 pound of weight, and you get $50,000 more dollars, or $275,000 more dollars for a company like us. And we're like a $10 million a year company. Mm-hmm. So I don't think we're anywhere near like Grumman. The point is, I mean, they were in there like shaving the heads off the rivets. I mean, they had the aluminum so thin you could see through it. It was translucent at one point. Like the hull of the limb was machined out of one block of aluminum.
Oh, damn.
Yeah, like imagine CNC machining a hull of something that large.
And that
That's what
way,
they did in those days. That's
so
crazy
in
to
that
think.
way, you're not adding a weld to it, right?
That's exactly right. No rivets, no welds, no seams. That's
Wow.
exactly right. That thing is amazing. So all that foil and shit, that's covering up the amazing the underbelly of this thing. There's lots of pictures of what the struts look like without all the aluminum, the mylar, all the tape and stuff on there. There's 100,000 pictures that you can go and see and watch them do this. They put it in a tumbler. It's like a 3-axis tumbler, which just sits there and it shakes it to shake all the little bits of metal and whatever else that they miss. And then they
Yeah.
go in there with camel hair brushes and they're like sweeping this thing, and then they pressure test them,
Yeah.
to figure out like, okay, are these windows going to be good enough? And windows were shattering and they couldn't figure out what the
Exactly
hell
that.
was going on. And there's like so many little things that they had to figure out, what's going to work? How's this going to work? And they changed it so many times that NASA just put a stop to it. They were like, you can't make any more changes. Like, keep it this way. I mean, at one point they had a round hatch,
Yeah.
and the astronaut couldn't get back in there. It's like, okay, we gotta change that. We gotta change this. They had so much more. Like, the whole thing was one giant bowl window. Whenever they got the contract and they realized, dude, glass is heavy as shit. We can't use that much glass on here. We got to get rid of that.
Do you think
You know?
that if a rocket wasn't obviously one of a kind, and they were, say, sections that are bolted on or needed to be welded, do you think we'd be able to do any of the things we're able to do now? I mean, if it was less technology to build these rockets, if they didn't have those machines that you're speaking of, or the ones that you guys use, do you think it would even have been possible to get to space? And I'm not asking like, is this a way that they couldn't have? I'm asking, like, honestly, in the fact that I'm starting to build the realization of how one of a kind these things are, and
Right.
If say they bought a cylinder of certain height and then cut it and didn't one of a kind it, you know what I mean? It was more manufactured.
Okay.
Do you think we would have been able to back then, able to even get
Like,
to space?
Okay. So you're asking me, with sort of like off the shelf parts,
Yes.
could we have gotten to space?
Yes.
Not okay. Yes. But I don't think there would have been people in them. I don't think there would have been people in these rockets without the very, very special gyros that MIT developed.
Yes.
There was a man, I think his name is Charles Draper. He was in charge of the MIT department at the time. This is a huge, like, controversial thing because, NASA is awarding this contract to a school, a university. It was MIT, and they already this guy Draper had already developed this sort of autopilot for a plane. It had been tested, and it flew from like New York to Los Angeles or something like that, and it flew itself. I mean, there were people on the plane watching it do it, but it was doing this with a gyro. This is how they navigated in space. It's like, how do you know where you're going? What are you doing? Well, they could do it with star sightings, and they tested that, and you can go and understand exactly how that was done and why that makes sense, because I didn't understand it. I still barely understand. It's hard for me to describe it, but at the time that I studied it, to try to understand it, I was pretty satisfied with it. I wasn't terribly interested in it, but I just wanted to know how it worked. And it is amazing how they did. And I can point you in the direction of a quick video demonstration of how they did it that just makes it so elegant.
Yeah,
it's so simple.
Yeah,
the solution, it's like you almost want to cry. It's so like brilliant. The engineers, man, they can do anything. They have a problem and then they solve it, and that solution is just like, that's what I love to see. I love to look at something, look at a photo, and I see, man, why is this material on the side of here on this particular limb, like on Apollo 15, it's all like messed up on the side. Look how bad that looks. like, what is that? And I look at all the different pictures of it sitting on the moon. I'm like, yeah, that's like terrible. Looks like it's shedding or something. And so I'm looking. I'm like, why isn't it there on like 16 or 17? Well, I found out in these, I dug and dug and dug for like a year before I actually, I mean, I didn't look straight for a year, but eventually I came to these papers that talked about, it was like a review analysis of that thing. I mean, we're talking like 1,000 pages long. And I came across this thing totally randomly, and it's talking about this ablative material that they had used on the side of Apollo 15 and what they did to change it. So the bell housing was changed for the like a longer stay. The engines were changed. There were so many changes that were actually made throughout these missions. Even the cameras were changed. They didn't bring the same cameras each time. They had better and better stuff as the years went on. So you're talking from 69 to 72. They changed a lot of stuff. The suits that they're in are very different.
Yeah, yeah.
If you notice in Apollo 11 and even on 12, what they look like the Michelin Man. They're really stiff.
Yeah.
Compared to the later missions. There was a lot of changes that were made to those suits, and you can go and look at those changes and see what they did and see the photos and understand why they made the change and what it was. And it's very satisfying.
I don't know the attributes of the older ones, but the newer ones, because like I said, I was just recently doing the NASA budget thing, and I think it was in 2013, I believe, is when they revised is the last revision of the spacesuit. I'm not 100%. Don't quote me on that date, but it's in that time range. But it was talking about their ability to basically actually have almost free motion, with the exception of life support. You're walking inside your life support, but but yeah, they're able to do more missions, more repairs with these new suits. That is what they were saying, and I think it wasn't until 2014 that the ISS actually got those suits, but I think that was when they really started, showing a lot more of the repairs they were doing on the ISS. Is around the time I think they got they actually started using the new suits. But I see that. See, I like this because now I'm actually it almost sounds like it shouldn't be the reason, but the actual one of a kind attribute any of this is having, I'm trying to figure out the word. It's almost exactly why when you watch a NASA live launch, the employees are so excited, and you're thinking, why are they so excited? It kind of now starting to understand why it is such a big deal. Why these missions were so known. You know what I mean? A lot of people don't know about everything, but it's making more sense to me why it was such a big deal. Because you're just the building alone and the designing alone would be, the second you go off the ground, be the biggest feat in the world. Yes. And,
the VAB, the vehicle assembly building, it's the tallest, like, one-story building ever. I mean, it has its own. It has clouds in the top. If you go down to the bottom and you're looking up on some days, if the humidity is just right, you see clouds at the top of this building. This is crazy. Where they actually assemble this rocket. It's enormous, and they did that for the Saturn V. That crawler, they designed that for the Saturn V. They're still using it today.
Yeah.
I mean, what tools built that? You know what I mean? Those tools don't exist anymore. They're gone.
Exactly.
They don't. They have updated these things and they moved along. So, but they had to. There's only one crawler, and they had to build that crawler with certain tools, and they needed very specific tools that they had to build in order to do it. So they're saying, whenever these astronauts say we can't do it right now, that's what they mean. Like there's no reason to have these woven steel, carbon, double carbon, whatever it was, gauntlets in their gloves, because they're not handling moon rocks on the International Space Station. They don't need to be able to take a fall and hit their helmet on a rock. They tested all this stuff. There's video of them testing this stuff. There's tons and tons of video footage of this. I mean, one of the requirements was that they were able to lift a dime with the glove. with the Apollo glove, and they were able to do that. Now they couldn't feel anything. That was the problem. There was a thing where Alan Bean, he's a jokester. Him and Pete Conrad on Apollo 12, they wanted to put these big giant hats on top of their helmets,
like a
and then take
sombrero
a
type
picture.
thing.
Yes, and then take a picture together. So he snuck a little timer that he was going to put on his camera, and he had it in one of these little satchels in his in the what is it, the EAC what's the name of it, ECB, in the front of this little pouch, and he couldn't feel it. He went in there and he was trying to feel for it, but there were also like some little moon rocks and things that he had collected. This is right before they got back into the lunar module, the second time, and he wanted to do it and he couldn't find it. But yeah, that was one of the things that unfortunately he wasn't able to do. But that would have been really funny to see two astronauts in one photo on the moon, because like, oh, who's taking that photo? That would have really started the conspiracy,
that would have been the one.
Anyway, there's so many, I think, just coming from this stuff, from just being interested in it over the years and not thinking about conspiracy as I've come to know these things, just being interested in this and reading so many books from the people who were involved, who built this. One of my favorite things is obviously the lunar module, because it's brilliant. Everything on that thing is made for a very specific reason. I mean, it is quite clearly no artist was involved in making that thing. That is the product of an engineer. That is totally engineer. He has it written all over it. It's like, it's ugly. It's an ugly thing, but it's also beautiful. Why they did certain things and how they did them, and the failures that took place, and the ones that took people's lives, and what they learned from that, and what they had to change in order to make this thing successful. There were so many things that were changed that.
And it would sound like an obvious, an easy answer question, but do you think if maybe they let those things known, because they don't talk about the testing. We were talking about that a little while ago. They don't talk about how many versions they had to go through before they figured out what was the perfect rocket to get these guys out there.
Right.
Do you think if they had not talked about everyone, but made that more known, that maybe it would have changed a lot of minds, or ideas of how it is? Because realistically, you don't think about, like, I'm honestly have never thought about the little obvious things that you've talked about, that in my brain I'm going, why didn't I think about that? Like, just the fact that they had to have been so one of a kind is, that's what I'll say, to be as easy as saying as I can, that it's more than possible that they did. They constructed this thing as perfect as a model of something that could fly to the moon and back as it could get. Like, there is no better.
Right.
Yeah. See,
it's absolutely amazing, and they predicted this. That the just like the gyro that was in there was put together by people who weren't really allowed to shower. They didn't want dry skin flaking off them and stuff.
Oh wow.
Putting these gyros together. I mean, they failed almost every test that they did. And NASA kept rejecting them. And these things were more precise than any watch on Earth. I mean, the way these things were put together in clean rooms, and it was just like brilliant. Like the way this thing was, if you have a 3-axis stationary gyro in the inside of this thing, and you had a starting point, say 0, 0, and you knew where that was, and you knew where you had gone, you knew where you were going. That was it. That's how this thing worked. And they had predicted this thing, so they had a computer telling them
for like the trajectory,
where they were,
like where they needed to be for the moon, and
that's exactly right.
Yeah, okay.
Loss of signal was going to happen at a very specific point, and they had predicted when this was going to happen. The accuracy that mission control predicted this based on what the computer was telling them, based on the gyro, was like within 1 second. They were counting down the loss of signal, and it was that like precise.
Wow.
Which is amazing. And then coming around the moon, they knew the the exact trajectory, the velocity, all of that. They knew if they didn't change anything, if they didn't use any of the RCS thrusters or anything like that to change their orientation, slow down or speed up, they knew exactly when they should reappear, get that signal back.
Yeah.
And they predicted that too within 3 seconds. I mean, that is like extremely accurate. And they're doing all this with math, just math, looking at the physics of this, saying if you have this much weight at that time and then you hit the thruster, okay, you just lost 5 pounds, 8 gallons. Okay, now you're dealing with this much mass. I mean, all of this was worked out. Every bit of this on paper. There was no like computers. I mean, there were some computers that actually helped them do this, but most of where they went, I mean, they wanted the computer to be able to do everything. They didn't want to, like, if they were cut off from mission control, they wanted the computer to do everything.
Well, weren't those
and it wasn't able to do that.
Weren't those computers like as basic, like they were programmed to do one thing, and if they failed, like it failed, like that program?
No. They had, this thing was programmed to actually land this thing on the moon. There was no reason for them to actually like take over at the last minute. Every single one of the, not the pilot. The pilot actually didn't do any of the flying. The pilot did more of the navigating, like telling
the computer,
the commander how far up, down, left, right he was, how fast he was dropping based on the ags and pings, which is 2 different radar systems.
So almost
telling
like
them,
almost like a submarine rather than a plane. Right?
Yes.
Okay.
Yeah. Basically, like a submarine and a helicopter. I guess it's hard to.
Oh,
yeah,
no,
I guess more like a submarine.
Okay.
Like coming down, so it has to flare up because this thing was going fast around the moon, like 11,000 miles an hour or something like that. I forget the exact velocity this thing was going. So it actually goes up and above the command and service module whenever it's slowing down. So it lets it pass basically, and then it starts its way down. And it takes about half an orbit to do that, and it has to land. I mean, this is some shit right here. This is one of the most amazing things that I ever figured. So Apollo 11 was the first landing, and they had a very specific site that they had already figured out based on the Lunar Reconnaissance Orbiter, or the Lunar Orbiter, actually, is what it was called. And this thing sent back some really high resolution photos, and that is a feat in and of itself. And this is actually in a book that I have because I'm obsessed with like antique photography and stuff like that. And this camera, there's one left that they actually used, and this thing was, not only was it a camera, but it would take the photo and then expose the film and then scan it and transmit that data back to Earth, and then they could print it out. Like that was what was going on in 1965. Like that is crazy. The technology is there.
Scanner.
I mean, it was a dark room and a fax machine. It was and then it sent a fax, a high resolution fax back to Earth. I mean, we're talking like extreme detail here, like it's such good detail that if there was a lunar module sitting on the surface, they would have been able to see it.
So that's
how good this was.
And then that's almost why 30 years later we can do the same thing, across the world. Is that like the same technology that would have eventually gotten to the public?
I mean, they had it at the time, but there were. I mean, we used these extremely large antenna to send and receive data from the moon.
Yeah. Okay.
They didn't need they needed unified S-band, which is USB. So when I talk about USB, they're like, we didn't have USB.
Yeah, I know.
It's called unified S-band. They had, they sent back, and this was like a tangled web, the subcarrier on UHF, this ultra high frequency subcarrier that was to send this stuff back and forth. And there were people at Georgia Bank. There was a guy in like Michigan or where was he from? North Carolina or something like that. He was listening to them like land on the moon with his own like shit at home. He was a ham,
Mm-hmm.
And speaking of ham, they had sent Ham up, this little chimpanzee first. He was the first. We were afraid to send a human up,
mm-hmm.
So we sent Ham up to see because they thought like the eyeballs would change shape and stuff like that, and they wouldn't be able to see the stuff going on in there, and they wouldn't be able to press buttons and all that kind of stuff. So that's crazy. And then they really didn't want to send Alan Shepard up. I mean, he I think he pissed himself that he sat on he sat in the rocket for so long waiting on them to send him up. You know, he was.
And he was the first.
And then
He was the first man into to.
American in space. Mm-hmm.
Oh, okay.
Little 12.
Was that into low Earth? And it was a return
That
rocket,
was
right? Not it didn't orbit.
yeah. That was a no. That was a 12-minute
Okay,
suborbital is what they call it.
Yeah.
So it went up and it would have made an orbit, but then he slowed it down and then came back down. So it was only a 12-minute in space type thing. If he hadn't slowed down, he would have made the orbit. But they're basically just firing. You know, imagine firing a cannon way up and then it's coming back down into the ocean. So that was the safest thing that they could do at the time.
Like an amateur rocket, but on steroids.
Exactly. I mean, they were checking everything. These guys were checking everything for hours and hours and hours. I think they sat on the deck for like 8 or 9 hours. You know, and he was in there, and they were just like, no one wanted to give the last call to just fire this rocket and let him go. You know, everything looked right, but everybody was just, these they didn't want to kill anybody. You know, they were like, shit, I don't know.
And that was that was like the first test to.
That was the very first. Yeah.
Oh, okay.
I mean, they literally took an intercontinental ballistic missile and took the missile off of it and put a little capsule on the top of it and put a guy in it. That's what they did.
And there was a guy brave enough to actually get in that damn thing.
Yeah, and
you can hear him cussing him. He's like, he's literally. You can go back and listen to this, and he's cussing him. He's like, light the damn thing, and then they finally just make the call and they do it.
Oh, he wanted to go.
Everybody is.
He wanted to go, but they didn't push. They weren't.
Yeah. No one wanted to be the guy that said go, and then the thing blow up. Because they weren't the most healthy. Like, I mean, the track record of these rockets, they had got it as good as they could. And, but yeah, like that first guy, no one wanted to be the one to pull the trigger on it and say, okay, because it was really, seat of their pants back then, but you can hear their excitement in the flight loop. They're like screaming like, yeah, they're going crazy whenever it makes it and it goes. And the excitement's crazy.
See, these are like the type of things that like, if I would have heard 5 years ago, 6 years ago, like would have given how real of a big deal it was, because they don't. I guess they try to make it a big deal, but they don't talk about these things. You have to, really dig deep to find these type of things, or finally talk to someone like yourself who, like, knows what was going on. You can express what was like the feeling of it, because to me, I always thought they kind of made it like, this is what we do, so we built it, we take it up there, and we take these pictures that make everything look a lot better than it is. But now I'm starting to get the realization of how it was on ground zero, basically. You know what I mean? Where these guys were actually doing it. And
it's reality is so much more amazing than this made up junk that they didn't go. It's I mean and here would be, I guess, because I need to go in like a couple of minutes, this is the last thing I want to say right now is just that this what I normally see on like YouTube and these forums and stuff like that are people asking questions saying something like, how is it possible that like, okay, there's the lunar module going up, the two guys are in that craft that's going up, but somehow or another we're seeing video footage of that. Like that question right there, they say it and they stop there. They don't actually go and look for the answer. That's the problem. They stop at that question.
Yeah.
No one ever wants the answer to it. The elegance of the answer and the solution to these things is so much more magical than this made up fantasy crap that they're saying. It really is.
Oh,
it's amazing.
You've definitely got me on. I took as many notes as I could, and I have a lot of things to look up. But just the fact that earlier you explained it, I'm thinking about it now, and it seems so simple, like ridiculous. I didn't even realize it. But remember, I was asking about the how they did the trip times there and back,
Uh-huh.
and it just dawned on me. It's like they sent a bowling ball, but by the time they were ready to come back, they were
It was
a
a
golf.
marble.
Yeah,
Yeah.
exactly.
Uh-huh. So much less mass. And actually, at a certain point, if you're watching the data stream coming back, and you can do this, there's several websites that have actually taken that data that you can go and look at the raw data, but they've taken that and they've put it into the timeline with the flight loops and everything,
Mm.
and you can literally see it speeding up because the Earth is actually they're falling back to the Earth. At a certain point, the moon's gravity is no longer affecting them as they're shooting away from it. So once they stop that rocket, whatever they did, it's not like they're going to continue to speed up or anything like that. That's just their speed for the end of time until something interacts with it. And as soon as the Earth starts interacting with it, pulling on it a little bit, you see it starts to speed up and speed up and speed up, and then it gets up to 25,000 miles an hour when it hits the atmosphere.
Yeah, that's
And check this out. One more thing, just explaining how that capsule was actually just like a wing. You can imagine an airplane's wing. The way that they were able to do this, because you're thinking like, how on earth could they skip this thing? Because what they did, imagine your hand sort of like going down, 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 down toward the ground at, like I say, a 45-degree angle. Well, then they pull up like a jet, like a fighter.
mm.
They pull up, and it gets extremely hot at that point, and then it actually lifts. It creates lift underneath this thing, and it cools off, and then it goes up, and then it comes back down. Like, that's how they did this thing. And
Oh
it's
damn.
truly amazing how they did that. And the way that they did it, they had these little RCS thrusters on the side. There's three of them on the side of just the capsule we're talking about. It's the last thing that comes in. It's
Mm.
the lightest part. They've shed every ounce that they could whenever this thing comes in, because they got to slow it down. So what they do is they make the center of mass on this thing lopsided. It's off to one side. So imagine this thing. It's Imagine if you set it down on a table, this capsule, and the shape of the bottom of this capsule has a radius.
Mm.
And imagine that it has nothing in it. It's going to sit flat and firm on the desk that you sat it on. Now take some glue and glue a bunch of rocks sort of to one side on the inside of this thing, and now it's going to sit lopsided
Yeah.
off to one side. That's basically what they did.
Oh wow.
They made it lopsided so they could use this RCS thruster to turn it, and all it can do
Oh
is
yeah.
is spin like a football,
Yeah,
a spiral.
exactly.
That's
Yeah,
all
yeah.
they can do. But it changes their center, that center of mass, and it actually sits lopsided on that table the way you think, and it creates lift, so they can literally fly a capsule.
Oh damn.
You know, Dude, it's so amazing, so amazing. Whenever you see how this thing works,
Yeah, I want to
you
look into
know.
that. Yeah, like I said, I took as many, jotted down as many notes as I could to look into things. But like you said, you had to take off. I you have no idea how much I appreciate just explaining it to me, because even this, what I thought was the most difficult thing to understand, is it kind of exactly like you said. It's kind of like it was so easy in my brain right now that I
Right,
wasn't looking for that.
right.
And
The solutions are so elegant and simple. Like they really are. They're sort of like exactly like that. And man, what's his name? Richard Feynman. Richard Feynman said something so interesting to me. He said, um, if you can if you can't explain the most difficult thing that you can imagine, like theoretical physics, something like that, to a 3-year old, then you don't understand it. You need to be
yeah,
able to. There's no reason that you shouldn't be able to explain this to.
you still there? I think you may have cut out. Or was that me? Soundly, can you hear me? No. I don't know if you guys can hear me or not, but I lost everything, or lost all audio at least. I think I may need it back. You guys.
Well, wait. Oh, before we move on to the next thing, like you need to, because he's like, dude, there's 30,000 things flying around in outer space, and I'm like, okay, well, how many people are there on Earth right now? It's like, so what, 7 billion? Okay, on an even smaller ball than the orbit of all these 30,000 satellites. I'm in my car right now, and there's a field to my left, a field to my right. I don't see anybody. There's nobody around me right now. I could drive for miles, and there's nobody there. Yet there's 7 billion of us on planet Earth, on a smaller marble than the marble of the orbits of these things. That's why they're so far apart. Why would you expect them to see one another?
Yeah.
You know, they're so freaking small, they're not. The cameras on them aren't exposing for those things.
And the people
You know?
that put them up there, know where everything else is because they don't want their shit to wreck.
Yeah. Yeah. That makes a lot of
Right?
sense.
Why would they put them next to each other? But they show that diagram. I hate that diagram because it's nice to see how many things are floating around the Earth.
Yeah.
But it doesn't. Dude, the scale of that is ridiculous.
Yeah,
it's completely wrong.
They took everything and smashed it into one area. Yeah.
That's right. It's crazy. Those things are, thousands and thousands of miles apart.
Yeah.
It's crazy to think that something the size of a garbage can.
Well, see, that was, and now that I'm thinking about it, it still is the same issue I'm having, but the reason I was a flat earther, a big part of it was just that the understanding and the image in your brain of what Earth is, just how big it is kind of what blinded me to a lot of things I need to be really, really looking at, and I think that plays a big part on like why I didn't believe a lot of things or why I didn't think things were possible. Just because what you see is a ball with just everything around it, when realistically those things are backed out, and that's the condensed version of it.
Right.
So yeah, I think, and I hate to say it, I think it's NASA's selling it. I call it selling it. If you know what that means. You know what I mean?
Right. I understand.
And I think that may be a big part of it, because what you've explained to me is like the details, the realistic things that were happening during these projects and sending people up to space, and NASA doesn't portray that at all.
I agree. Yeah. It's you have to dig deep for this kind of stuff. I mean, I had to go and get books that were written by the people who built this shit. It didn't come from NASA. It came from the people who built this shit. I wanted to know who made this damn car that went on the moon? This damn bra company, that made ladies' undergarments and stuff, that, they were really good at sewing, so they made the spacesuit. They were the ones who were awarded this thing there were all kinds of people. And this, the ice particle sublimator, this thing that actually like got the heat away from this, the heat exchanger.
Okay.
And you're going from that thing is amazing. I do not understand how that thing works. In the personal life support system, that thing that was built by Hamilton Standard, that thing is amazing. Like how it exchanges heat from the body of the astronaut, because how do you get rid of the heat? How is it possible to get rid of the heat when you don't have convection? You don't have you don't have convection. You just have radiation. So it has to radiate, but it has to do it with this ice sublimator. So it goes from a liquid to like a gas. And the way this thing works is like I do not understand how.
So basically, inside those suits were like their own atmospheres.
Yes.
Yeah.
The garment that they wore, the undergarment, is a series of tubes, like hundreds of tubes with ice water running through them.
Wow.
Constantly, and this thing, I mean, imagine if you were to put your hand behind the lunar module into the shade and half of it was in the sun. You're talking a difference of almost 500 degrees.
Oh, wow.
Because there's no atmosphere to help exchange this heat around or do anything with it. So I mean, basically all they had to do was reflect as much of it as possible with the suit. And if they made everything out of with a white material on it, or something that reflected most of the, I mean, and you can figure how much heat would be absorbed. And they figured all this stuff out, and they were able to replicate it here on Earth in vacuum chambers. You know, humongous vacuum chambers and altitude chambers and stuff like that they use for the Air Force. And they have some gigantic ones that they still use today. I mean, I think they just refurbished it a couple of years ago, but it's enormous.
Really?
I mean, they were able to put the entire
I
spacecraft in there and test it.
Oh,
You know,
okay.
and pull
So,
all the air out
oh
of it.
wow, I didn't know it was that big. Wow.
It's dude. It is humongous.
It-
It's like 8, 10, 15 stories tall. I don't know how big it is. It's humongous. This thing is huge.
Is it? Because I think I actually saw an image of where they built a Saturn V, and I think they still use that today, right?
Yes.
Yeah. Okay. So
Where they,
yeah.
where they put it together. That's the VAB.
Yeah.
The vehicle assembly building. But they
okay.
actually designed and built those rockets. Some of them in the F1s were, I think they were built like in New Orleans or something. Like I want to say like in,
It's yeah.
man, I can't remember. I know a bunch of them were in Huntsville. Like the majority of the stuff was going on in Huntsville, Alabama.
They
All
were
these,
they were engineering some really large stuff in New Orleans because they could put it on a barge and then
yeah, that's right.
Okay.
That's right. And they can move it, and they're you know, it's really interesting how they put all this shit together and came together and made all this happen. The guys from Huntsville were, this is Von Braun and his team. I mean, they basically kidnapped these guys from Germany, these Nazis, you know, and they were the only ones doing the rocket stuff. And
my great uncle is one of those engineers. If you're interested in reading his book,
man, I would love to. That's awesome. That stuff it's so interesting to me. Like that the Saturn V rocket, the stuff that they had to do in order to put that thing together is just incredible. Like the math involved in it.
You want to hear something interesting? He was a NASA engineer, and he was taking his experience with the exactitudes of their engineering, like how exact they had to be to keep these people alive, basically, and the way he said it was basically a tin can floating in, or what do you say, a tin can with the atmosphere on the inside of it, or something like that.
Yeah.
Or exactly how he said it, but
yeah, basically,
he was pointing this out, saying, and how much more refined is the universe.
Mm-hmm.
And like he was actually making that as an argument for God. There's a NASA engineer using his experience there as an argument for God, and yet the flat earthers want to say that they're all Satanists. You know, it's like that's what kind of personally insults me a little bit.
Oh yeah, and that's the thing, because I'm not religious. I don't believe in a creator, but at the same time, who am I to judge anybody for what they believe, let alone from what I see? It's kind of like a double-edged sword. It's like they're saying they believe in a God, but at the same time they're intensely hating people just because of what they believe, and then they want to use that against them as well. And it's like that's always confused me.
Yeah, it is a shame, really. There are a lot of level-headed flat earthers out there. It's not every flat earther, and we have to be careful when we say flat earthers too, because it's not all of them. It's this specific set of, like,
100%.
I don't know, gurus or something. You know, whatever you want to call them, like the Nathan Oakleys and the
24/7s.
Yeah, the 24/7s, exactly. Like they just have this mixed up idea that everybody's out to get them, and it's just not that way. It's the exact opposite, really. Me and Dandy talk about this all the time. I mean, we really want to help these people.
I mean that's it. I look at, like, my brother is the reason that I got, like, I was like, oh, I got to do something about this, you know, because my brother, he's a beer drinking son of a gun. You know, he listened to, like, boring music. He had a boring life. It just, like, to me, there was nothing going on. He'd go to the bar, he'd go to work, come home, play video games. That's all he did. He never read any books or did anything to further his education after high school. In fact, he dropped out and joined the Marines and paid somebody to do all the work for him to get his GED with his correspondence courses. And then, like, he never learned anything else. And 10 years goes by and he gets bored in his marriage and in his life and attaches to this thing that he's never even heard about before. Now he thinks he's got something that no one else has, and it makes him special and unique. And I'm like, Robert, this isn't you. Like, you don't, I feel like you have, jumped onto this belief. And right now, just talking to you, Sean, I would say, I would be more careful about, saying I believe this or whatever after,
Hmm.
like even with this moon stuff. I'd say if someone asked me
Oh,
tomorrow, I'd be like, I don't know, man. I mean, there's a lot of stuff here and there that I question, but I wouldn't be like these other guys who are just they just want to have a belief. They
oh no,
just
no,
like,
yeah. Like I said, I took a lot of notes from this conversation, and I'm not gonna say I fully don't believe it or do believe it, but I now have an understanding of how it happened, and I can, even in my mind, see how that happens, and now I have something to look into to understand everything in between. Um, no, no, I trust me. I want to. You've probably been the best explanation of Apollo and just NASA in general, and then the engineers that were bigger than NASA. Um, it's something that I think anybody, not forget flat Earth and globe, anybody who doesn't, who even believes in it, still needs to hear the details of it more than we're getting. Like I said, I think the biggest thing is helping me right now is just the understanding of what it actually took to do it, not just they did it.
right, because if you say, okay, like, I guess what I did, and I didn't do it from the standpoint of conspiracy theory. I did it from the standpoint of, I'm very curious about the engineering that went behind this. How did they do this? How did they get to the moon? Like, this is amazing. And I wanted to know every single detail about it. And that's what I did. And for years and years and years, I've accumulated these things. And I'm not like a guru or an expert at it, but I have tackled each and every one of these things over the years. And it's kind of like whenever you go to school and you learn these things and you forget them over time. Like, I can pull little things out, and I can't remember exact details, but I can kind of, like, if you say something, it will spark me up, and I'll go off on you like I did tonight about all these different things that are just
Yeah,
so
yeah.
amazing and unique and one of a kind, and just like what it took to do. And there are books and manuals and specifications out there, blueprints and work instructions that you can go and see, and you can look at engineers' notes and things like that, and you could see, oh, the first time they went to go test the leg that extended on that lunar module, because it had to extend its legs at some point. They had the springs, like it got stuck, and one of the engineers went over near it, and it fucking pummeled him, dude. It pummeled him so hard it killed him.
Oh,
And
damn.
and and they and they they just kept working, scooped him up, and they had to go. I mean, this was 24/7 for 9 years, 24 hours a day, 7 days a week. You're talking thousands of divorces. These men worked 80 and 90 hours a week. I mean, they literally like lived there. They ate, slept, and breathed it. It ruined so many families. And these people talk about it, and it's, I mean, this is the real deal. And every single little part of this thing that was done, I mean, it would have had to be, okay, where can I satisfy myself when it comes to, were they capable of doing it? How did they do it? Okay, here's a problem. How did they get up there? Okay, was that rocket powerful enough? Let me learn about the rocket. Let me learn how rockets work. Let me learn how, you know, where was it tested? How many tests were done? Can I find that data? And you find all that stuff, and you see the people who did it, and you see, oh, there's people who wrote books about this stuff who can help you understand it. And they actually touched it. And they'll talk about, the different pipes that they had to change from rubber to something that was solid because it was rattling up there. Like all these little things, and each little step of the way, they learn more things.
Yeah.
These oscillations that were happening. So they put these big, like, shock absorbers inside there, so it would stop doing that. You can see, if you watch the lunar landings, you can see it oscillating. You can see that lunar module oscillating because of the fuel. So this thing is going down, 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 and it's constantly like boom,
Sloshing, yeah.
boom, boom. That's because the hypergolic fuels are sloshing around in there. So they had to put little baffles in there to keep, like, basically segregate little sections off inside of there,
Yeah,
so it wouldn't do that.
yeah, I know
You
the
know.
baffles are, yeah.
And so, and then the next one you see, it's, oh man, it's like way better, on the next one. But that wasn't said. That they didn't say anything about that.
Exactly.
You have to go and look that stuff up, and
Yeah.
you just sort of discover these things over time. It's not something that you're necessarily looking for, although you can, if you're truly interested in one specific thing, you can definitely go look that thing up. But all these other things that I'm talking about are just things that kind of just came to me over time, and then reading these books and reading these manuals. And I mean, dude, I'm like embarrassed to say I've gone, like, I have the transcripts printed out, and I will literally like listen to this thing over the course of a couple of weeks, you know. So I'll listen to 3 or 4 hours at a time and go through it, and I circle things, and I'm like, oh man, that's really interesting. What does that mean?
Yeah,
You know, and I have to Google that and look that up, and I'm such a nerd. But yeah, that's the kind of
that's awesome. Actually, I like that. That's like the detail is that important to you.
it is. I mean, I have a whole room dedicated to Apollo.
Nice.
So I'll take a picture of some of the stuff that I have and show you. It is
That'd be
such
awesome.
a nerd thing. I mean, I have stamps that were, you know, created in those days that sort of, you know, it has like the lunar module on one of them, and you know, I have all the patches from Apollo and Gemini.
Yeah.
That were actually made by the company that did the original one, so they're perfect replicas, you know, made by the same companies.
Nice.
I mean, I have just a ton of really, really nerdy Apollo stuff. And
No,
I
that's
don't know.
cool.
It's just I've always been obsessed with it. It's just been I don't know more about anything else. You know, this is the thing I know the most about.
Nice.
But I'm really curious and interested in it. And if you have any questions, man, I would love to point you in the right direction. There's so many sources out there that I've come across, and I'm like, man, why didn't I know about this earlier? You know, and
Yeah. Well, and
there's just so many places.
any link source you can give me in the back chat of here, please leave them.
Yeah.
I will look at all of them because you got me interested.
For sure, man.
Because like I said, I wrote down a bunch of stuff, and there's just phrases you said that like I wanted to like look up and kind of figure out like how that was done, or like you were talking about the gyro system. Like I know what a gyro system, but
Yeah.
because I know like how the computers worked then, like how advanced that must have been for everything they were using around it.
Yeah. I'm actually watching this guy. There's a group of guys who, okay, this guy bought 2 tons of Apollo stuff at an auction. This is years and years and years ago. And he had it in this, like not a warehouse, but it came from a warehouse. This is like back in the 80s or early 90s. Yeah, like 91. This guy bought all this stuff. 2 tons of Apollo stuff, you know, that was left over. It was just sitting over somewhere. So in this stuff, they realized recently that there was an AGC. This is the computer that landed them on the moon, and he has one. He has one of the Block 2s, one of the second revisions. So that the third revision is the one that flew. So this was a non-flyable unit, but it is the computer, and they're rebuilding it right. Like they're going right now, like circuit by circuit, and making sure this thing works properly. And they got it to. They're doing it right now. Like he just uploaded another video today, like going through this thing.
Oh yeah.
You know, it's amazing. I mean, this thing did what they said it did. You know, and they are using a type of emulation to feed into this thing. You know, get it to fire different alarms, stuff like that. Like
like a circuit tester.
Yeah, I mean, yeah, exactly.
Okay.
They're replicating with emulation based on all the data that they got to feed into the actual computer, so it doesn't know the difference. So it's going to respond to whatever they put into it.
Yeah.
You know?
Okay. Yeah.
And it's really cool, man. It's actually working. It's doing what it's supposed to do, and they got it to do like a main B bus undervolt, the thing that happened on Apollo 13. They're getting it to. They got it to do that the other day. You know, it's like that's really cool, man, to see this stuff, and you know.
Yeah, it would put in, yeah, like I said, I can't. It would put in perspective exactly what went on if they were like this stuff was more open to everybody rather than, you know, like you were saying, having, you know, you have had to dig your whole life to find out a lot of these things, and
I still have,
man,
I haven't had answered. I have them in an email to myself, you know, and I add to it sometimes. And sometimes I come across something, I'll be able to cross it off the list.
Yeah, that's exactly what I do.
You know, it might take years to answer these questions that I have, and I might actually have to meet these people in real life. And I've already spoken to some of them at LPI, and I'm going with like a handful of solid state hard drives. They were like, yeah, come to our library, you can have anything you want.
Nice.
I'm like, fuck yeah, dude. So I'm gonna go and just like strip their whole computer of everything that they have. They have it all. They have everything.
Nice.
You know, they have every raw image that's ever been done in the highest resolution possible. So I don't have to go and download them one by one on the internet. Which is such a pain.
So I'll ship you
So
mine. I have
yeah,
a little export what do you call it? External hard drive. Can I send that
yeah,
to you?
dude.
You can load it up.
My dream is to have every single one of them and just play them
Yeah,
in a quick time lapse and stop on some of them that are really interesting,
that's
you
cool.
know, just for seconds, and just have some really like good ambient music or something to go along with it, and just show and just, you know, put little captions above each
Yeah, yeah.
roll of film, you know, and maybe give some little details about it as it goes. But
Yeah, that'd be
there are
awesome.
literally thousands of pictures of the Earth from from space, you know, that were taken on film, and
And
you can go and see that film. You can go and hold it in your hand. I mean, I don't know if they'll let me, but I've watched other people do it,
like,
you know. But you can go there and look at it. It will let you do that.
those
It'll
are like
let you go and look at those films.
those are the raw images too, right? They're nothing's touched up and
That's
nothing's.
right. They're in a
Yeah.
freezer. They're sitting in a freezer right now. All those original films, you know.
See, that's another thing that I've always had an issue with, and also, almost got me to into the flat Earth thing was if you Google search raw images of space, it's not easy. Like, you have to really search to find actual, you know, images of what's going on in space that are raw images, and then they're all
Yeah.
usually black and white or
Right.
super fuzzy. But
Right.
even then, I think if there were more of those, there wouldn't be so much, like, like I was saying earlier, selling space images, because
Right.
that was one thing that frustrated me the most. It was because I was always the type that went, all right, well, that's Mars, but what does Mars look like from an image that's not, sold, so to speak?
Right.
And
Yeah.
it's actually really hard to find, really
Right.
hard.
Yeah, you're right. It is. You can go to the Opportunity and Spirit rover thing. I mean, they upload to that site as they come. So those are raw images if you want those. They have some of them are low scans, some of them are high scans, but that's, I mean, they're still coming. I saw one of them hit the other day that came through, and it goes straight onto that website.
What was
You
the
can
website
download
again?
every single one of them.
What was the website again?
Um,
Or if you remember, just you can send it to me. Like,
yeah,
in this
I mean,
hangout or
I
something.
have all this. I have every one of these websites in my favorites. I'll link you to it, and then I'll give you a description above each one, like what it is. So
that'd be
so you can.
awesome.
Yeah, this stuff. I mean, I still find stuff today. It's like, man, this is amazing. I was listening to this Jeranism video the other day for the first time. I'd never heard a Jeranism video, but he was talking about the space station. One of his arguments was that you're supposed to be able to watch this thing live 24/7, but every time it goes into the darkness, it cuts out. And I'm like, that's not true. I've seen city lights on this Ustream, you know? So I pulled it up, and there it is over the Atlantic Ocean, in total darkness, looking down. It's like, it didn't cut out. It's still there.
It's wonderful because Sally knows exactly what I'm talking about. There's a guy in a server in Discord who tried to use at a certain point in time that exact argument. The camera cuts out. That's what proves flat Earth, and and the whole idea of it just boggled my mind because I'm going. You're using a globe model ISS tracker to prove flat Earth. Like, what is the actual trajectory
you're
of it?
live stream from space to prove flat Earth. Wait, what?
And it boggled my mind. He juggled whether or not it was really in space or blah 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 blah. But yeah, that's one of the things that boggled my mind when it comes to the hoaxes and the this and the that. It's the extreme people will go. Like, I've always said to people, it's like, why don't you just, like, because this is what I do. I was like, start on it small. Don't jump into it thinking everything you read is going to be solid. Like, for instance, my main research is like the climate control, the geoengineering that they've been talking about doing, and right now that's like pretty much engulfs all my research time. And people don't like. It went from weather modification, and that was what I first was arguing in certain places, and everyone was like, Sean, you're crazy, they don't spray. And I'm like, no, not chemtrails, because that's what I've always tried to. I hate using the word chemtrails because of what it's become.
Right. It's kind of been hijacked. Yeah.
Exactly, because what's actually is happening is they want to spray chemicals into the sky. Weather modification, they spray chemicals in the sky, but it ruins it because I cannot say chemtrails without getting jumped on for crazy outlandish ideas like nanobots.
Yeah.
And,
Those two have been like combined at some point. I mean, I know about it because my parents lived in India for 3 years, and
yes,
they do the cloud seeding over there, and it's
Yes.
like they're trying to get rid of the smog, and they have to do this, and it's horrible during that time. You know, they call it the rainy season.
well, I've always
It's
looked
like,
at
dude,
it as
this is
yeah, I've always looked at the weather modification with its little nicks and quirks of bad, for outright or basically good. The geoengineering is what gets crazy because then you're talking the world, and
Right,
That's
yeah.
the crazy part.
yeah. I don't know. I mean, I have not really looked into the chemtrail stuff enough to really have a strong opinion on it. I figured by now somebody would have said something, especially like with the Apollo stuff. Like, why would there's so many people involved, and
Well,
even
see-
if there were 5 of them involved, why would they?
Well, see,
I don't know.
that kind of goes both ways because
Or expensive to accomplish.
Godspeed, John Glenn.
Roger, 0J, and I feel fine.